Hi there, thanks for joining me. We're talking about solving systems of linear equations, and in this video we are focusing on what we call the elimination method. So as a reminder, a system of linear equations is basically a set of linear equations, more than one. So we have more than one equation, and what's important is that we are solving them simultaneously. What does that mean? It means that we're looking for one solution for all the variables. In this case, in this example here, we have x and y. So we're looking for one ordered pair, x, y, that will solve all of the equations in the system. And when we talk about the elimination method, we're talking about a method where we try to get rid sort of a term. What does that mean? Well, I wrote down here the steps for using the elimination method, but I will use this example to go step by step and show you how it's done. Now, because the elimination method is probably the trickier of the three methods, there's the substitution method and the graphical method. I would say this one is a little bit trickier. Because of that, we will look at more than just one example. We'll look at two examples. So let's get started. Our first step is to use the division or multiplication properties of equalities to make two terms look alike. What does that mean? Well, if you look at this example here, we have a term in y, 2y, we have a term in x, and here we have the 7x and a single y here. What does it mean that I want two terms to look alike? Well, for instance, I want to have the same coefficient for y in both equations. How will I do that? Well, let's take this equation and multiply both sides by 2. What do we get? We get 2 times 7x plus y equals 2 times 3. Right? We multiplied both sides by the same number, and so the equality still holds. Now let's open our parentheses. We have 2 times 7x, that's 14x. We have plus 2 times y equals 6. Now look, we have a 2y here and we have a 2y here. Now let's write these equations one on top of the other again. I'll just rewrite this, switch back to black so that it's clear. We have 2y plus x equals 6. And now I'm going to change the order of these two terms. I'm going to write it as 2y plus 14x equals 6. Okay, so we have these same two terms. Now, let's call this side A and this side B. We know that A equals B on this side, but on this side as well, we have let's call it A prime and B prime. And so what we can do is we can write B minus B prime equals A minus A prime. Why is this true? Because A prime equals B prime. So we are subtracting the same number or the same expression from both sides. So although 6 doesn't look like 2y plus 14x, we know that they're equal. So we are subtracting the same number from both sides. So let's do that. So we have 2y plus x equals 6. Now let's subtract from this side 2y plus 14x. And let's subtract from this side 6, right? Because this is our A prime here, and this is our B prime. So what do we get? We have 2y plus x minus 2y plus 14x in parentheses equals 6 minus 6. Okay, so now on the left here we have 2y plus x minus 2y minus 14x. We open the parentheses, and we have 6 minus 6 is just 0. But look, our 2y and negative 2y cancel. And so we're left with negative 13x equals 0. What does this mean? If we divide both sides by 13, we get x equals 0 divided by 13, which is just 0. So our x is 0. Okay? That is our solution for x. Now we can take our second equation. Let's make a little bit of room here. Let's take our equation back down here again. We have 2y plus x equals 6, but our x is 0, so we get 2y equals 6. Let's divide both sides by 2, and so we get y equals 3. Okay, and so our result is 0, 3. So that's how we use the elimination method. On the right here is a graphical solution, which again is at 0, 3 as well. And you can look at the video for graphical solutions in order to understand how we get that from the intersection. So this was our first example, and as I said, because it's a little bit tricky, let's look at another simple example. Let's look at the example 4x plus y equals 7, and our second equation will be 3y plus 2x equals 11. Okay, so what do we do here? Let's multiply by the second equation by 2. Okay, so if we multiply this second equation by 2, we get 2 times 3y plus 2x equals 2 times 11. So we open parentheses, we get 6y plus 4x equals 22. Okay, again we have a 4x here and a 4x here. So we would like to subtract one side of the equation from the other, right? So what do? Let's bring this equation down here and let's write it as y plus 4x equals 7. Okay, so now let's subtract these equations from each other, right? We're subtracting the left-hand side from the left-hand side and the right-hand side from the right-hand side. So we have 6y minus y, that's just 5y, and we have 4x minus 4x, so no x's, equals 22 minus 7, that is 15. If we divide both sides by 5, we get that y equals 3. Okay, so y equals 3. So let's write our ordered pair. Y and x equals, we don't have our x yet, but we do have our y, which is just 3. Okay, how do we get our x? Well, we substitute again, right? We substitute, so we get 4x, let's use this one, 4x plus 3 equals 7, because our y here is 3, so we get 4x. Let's subtract 3 from both sides, so we get 4x equals 4. I'll write that down. We're subtracting 3 from both sides. If we divide by 4, we get x equals 1. So our solution is 1 for x and 3 for y. And you can take the time to check that the solution does solve both these equations. So these were our original set of equations, and you can check that they solve it. So thanks for joining me. I hope this video was helpful, and if it was, please like, and I will see you in our next video.